Hi, good morning everyone. This is Kumar. Welcome to BBC channel. Today I would like to explain about graph representation. It means that generally the graph is representing for the mainly three types. The graph data structure is represented using following representation. That is the adjacency matrix, incidency matrix, and adjacency list. The mainly three types of representation in graph. The first one is adjacency matrix. In this representation, a graph G, the generally graph is representing for G. That is G of V, comma E, with V vertices and E edges, can be represented using a matrix of size V by V. It means V rows and V columns. It means, for example, the 5 vertices in present graph, the matrix is 5 by 5. In adjacency matrix, the both rows and columns represented vertices and the value of the matrix is either 0 or 1. Here, 1 represents there is an edge from row vertex to column vertex. 1 is representing for the edge from row vertex to column vertex. And 0 represents there is a no edge from row vertex to column vertex. It means no edge between vertex to vertex, that is representing for 0. In case the direct connected to vertex, that is representing for 1. For example, this is for the undirected graph. The first, choose the undirected graph. In this, the A, B, C, D, E, there are 5 vertices in graph. So the matrix also 5 by 5 because of V into V. So the B is a self loop. Okay, it is in a one edge. It is a little bit different. So the A to B is one edge, A to D one edge, A to C one edge, and the same way C to D and one edge, D to B one edge, and B to E one edge, D to E one edge, and B is in a self loop. There are mainly 5 vertex. The matrix is representing for the 5 by 5. So first of all, represent vertices A, B, C, D, E, and at the same way columns also A, B, C, D, E. So in this, the first row, the A, it is not in a self loop, so it is 0 because of A to A cannot connect. It means no edge for A to A, so it is representing for 0. And A to B is connected, that is representing 1. The same way A to C is connected, so that is representing 1. The same way A to D is represented edge, so that is also 1. A to E is a cannot connected, so that is 0. That is for the first row. The second one, B. B is connected to self loop, that is B to B. And the same way B to A is connected, B to D is connected, B to E is connected. So B to A is connected, so 1. B to B it is a self loop, so 1. B to C is cannot connected, so that is 0. B to D is connected, that is 1. At the same way B to E is connected per X, so that is also 1. Now C, third row. So C is connected only for the A vertex and D vertex. So only the C2A and C2D are representing 1, the remaining all are zeros. And now D row. D is connected to 4 vertices, that is A, B, C and E also. D only not connected. So the D to D is a no self loop, so that only 0, the remaining all are 1. So move to E row. E is connected B and D. So B and D is representing ones, the remaining all are 0. This is for the undirected graph. It's clear. So now directed graph. So directed graph, the A is connected to B, D and C. So 3 are ones, that is A to B1, A to C1 and A to D1. Because of A is connected to A to B and A to D and A to C. The remaining are zeros. Now B. B is self loop connected and B is connected to D and B is connected to E. So B to B1, B to D and B to E1, the remaining are zeros. Now C. C is connected only for the D. Is a directed graph. C is connected to D. The remaining all are zeros. So C is connected to D, that is 1. The remaining all are zeros. D is connected only for the E. So D to connected E, that is 1. The remaining all are zeros. The E vertex is do not connect any vertex. So the all are zeros. These were these two way to represent the eccentric matrix. The next one, incidency matrix. In this representation, a graph G, V, comma, E. This is general representation with V is vertices and E is edge. Can be represented using matrix of size V into E. The previous is representing V to V. It means number of vertices into number of vertices. But incidency matrix is representing V into edges. It means the V vertex are number of rows and E is representing for number of columns. That is V into E. In this, a graph with 5 vertices and 8 edges can be represented in a 5 into A incidency matrix because of 8 edges and 5 vertices. In incidency matrix, row representing vertex and columns representing edges. This matrix is filled with either 0 or 1 or minus 1. The previous adjacency matrix is representing only for 0 and 1. But incidency matrix is representing 3 values, that is 0, 1 or minus 1 also. Here 1 is represented that the column edge is outgoing edge. It means in case is representing for the outgoing edge is 1 from is outgoing edge from row vertex. Okay, so outgoing edge is representing for 1. Minus 1 representing that the column edge is incoming edge. In case the incoming edge is representing, that is represented the minus 1. And 0 represented that the column edge is not connected to row vertex. It means no connection between the two vertices. That's representing for 0. For self-loop edge, only 1 is used to represent both the incoming and outgoing edge. It means in case if the any vertex is representing self edge, that is representing for 1, either incoming and outgoing also. Okay. The now undirected graph, how to represent? the matrix, incident matrix. So in this example, the 5 vertices, that is A, B, C, D, E, that is representing for the rows, and columns is representing for the E1, E2, E3, E4, E5, E6, E7 and E8. So that is for the column. So A is representing 3 vertices, that is B, D and C. So A to E1 is representing 1, A to E1 for 1 and A to A3, E1, E2 and E3. That is for the 1, the remaining all are zeros. Now B. B is a self loop. So that is E6, that is representing for 1. And the same way B to A is representing for 1 and B to D and B to E is representing for 1, remaining all are zeros. Now C. C is connected to A and D, that is the E2 and E5. So C is E2 and E5 are representing for the remaining all zeros. Then move to D. D row, that is D is connected to E5, E3, E4 and E8. Edges are connected, that is representing for 1, the remaining are zeros. E. E is connected to E7 and E8 edges, the both are representing 1, the remaining are zeros. This is way to represent the matrix. Now choose the directed graph. In this directed graph, A is outgoing edges, that is E1, E3, E2. So 3 are representing for 1, the remaining all are zeros. B is self loop, that is E6, that is representing for 1. And B is incoming, that is E1, so that is the -1. The incoming edge are representing for the -1. The remaining two E4 and E7 is outgoing edges, so that is for the ones, so E6 and E7. Now C. C have one incoming and one outgoing edges. The E2 incoming, the E2 is representing for the -1. E5 is outgoing, that is for 1, the remaining all are 0. Now D. D have 3 incoming edges and one outgoing edges. So E3, E4, E5 is incoming. So 3 are representing for the -1. And E8, that is outgoing edge. So that is for representing for 1. E. E have an 2 incoming edges, that is the E7 and E8. The both are representing for the -1. The remaining all are zeros. In this way, the directed edges are representing for the incidency matrix. Adjacency list. In this representation, every vertex of graph contains list of its adjacent vertices. An adjacency list is an array of separate list. Each element of array A is a list which contain all vertices that are adjacency to vertex. That means in this example, I am choosing only for the 4 vertices and 4 edges. The 0 is connected to 1 and 2, and 1 is connected to 0 and 2, 2 is connected to 0 and 1, 0 is connected to only for the 3. So in this, the first the vertices numbers are representing, there is the rows 0, 1, 2 and 3. 0 connected the 3 edges, that is 1, 2 and 3 also. So 0 is representing for the 1, 2 and 3 also. And 1 is connected to 0 and 2 only. So 1 is connected to 0 and 2 only. 2 is connected to 0 and 1. So 2 is connected to 0 and 1 is representing. 3 is connected only for the 0. So 3 is connected to 0. In this way, the individual array is representing for the adjacency list. The list is nothing but an arrays. It's clear?